So we go to assignments, and I want to look at homework 1B here. Open section 1B. 15 questions. Let's see what we can find. Okay. First question is asking which of the following corresponds to B intersects C. I will say this. WebWork is terrible about displaying images, okay? When you first open this, a lot of these are going to be empty. Of course, mine are all displaying because I've already looked at it. My computer's already saved the images. A lot of times you're going to have to click these images over and over, refresh the page to eventually get them to show. It's a known problem, but that is the truth. So you will have to continuously refresh the page until all of them show up. Don't hesitate. You just keep clicking them. If they show up, then you can refresh the page and show it. So it's going to be annoying for sure, but they will eventually show up. Okay, so B intersects C. This is what B and C have in common. Actually, the first one here works. We have A, B, and C. What do B and C have in common? They have this little sliver here. We can see that this is not true. This is the part of B that has nothing to do with A, the part of C that has nothing to do with A. That's not what B and C are. This would be B union C. So that could be easily confused, but this would not be B intersects C. And then this would be B intersects C minus A, but that's not what we want. We want all of this. So that can't be true. Okay, so that's why I would choose the first one. Yours will be randomized of what it's asking, but that's how I would choose my answer. Okay, B intersects C complement is kind of like asking what is B minus C. So we want the part of B that has nothing to do with C. That's what we're going to look for in this problem. That would not be this. That's everything but B and C. B and C complement. We don't want that. What we're looking for is B minus C. This would also not be right because we have outside. We just want the part of B that has nothing to do with C. So we're really just looking for this part here. And that looks like it's this one. So this would be the part of B that has nothing to do with C. So just be these two pieces right here. So that's how I picked that one. Okay, now this one's a little bit more complicated. It has a parenthesis here. And how I would suggest to do it is I would suggest thinking about it with the parentheses first, understand what the parentheses is talking about, and then you can tackle the whole problem. So the parenthesis says A union B. A union B is putting all of A, all of B together. And then we want to intersect that with C complement. So what does that have in common with not C? It's kind of like saying A union B minus C. That's what this statement is saying. A union B minus C. That's what it's saying. So we want just all of A, all of B, take away the C parts. We don't want C. Okay, so that would not be true for this part. No, we want A and B. We just want to take away C. And this is not it. This is kind of looking like it here. We have A and B, and anything to do with C is taken away. So this is what we want. We don't want the outside here because we're asked about the intersection, or at least in my version of the problem, we were asked about the intersection. So we don't want this outside. That would be a different problem if it was a union. Okay, so we don't want that. So this would be the correct answer for A union B intersects C complement, which is like A union B minus C minus C, yeah. All right, this is very similar, except it just talks about regions, and it's a multiple choice question. Select all the regions that would be shaded with A complement union B complement. Well, with this, we can recall De Morgan's law. That would be the same thing as A The opposite of A complement is A. The opposite of the union is the intersection. The opposite of B complement would be B. So by De Morgan's law, we have the opposite of the intersection. We have A intersect B complement. So it's everything but region 1. We just don't want region 1. So that's what De Morgan would say. And so that's how I would simplify that problem for myself. Okay. So hopefully that helps. All right. Select the regions which must be shaded. We did this. This is in the lecture notes. A complement intersect B. That's like saying B minus A. Okay. So it's the part of B that has nothing to do with A. And that's just going to be region 3 here. Okay. All right. This one has 2 parentheses, so I would certainly understand what each parenthesis is talking about before I tried to tackle the whole problem. So A complement intersect B complement is A union B complement. That's what this first part is. And then this part is kind of like talking about A minus B. Okay. So A union B complement, A union B is region 4. Oops, I should do a different color. So A union B complement is region 4. And A minus B is over here, to region 2. And we want to put those together. Okay. So the union of these two ideas must be region 2 and region 4. So that's how I would work through that type of problem. Okay. 7 should be fairly easy to do. If the others made sense, you're just trying to solve what this one is. You have many different choices there. So that should be fairly easy to do. Same as this one, you only have one Venn diagram to understand, and you just need to choose the one which best represents that. Very similar to this. You are looking for which would best represent this Venn diagram. This is B minus A, so you just want to maybe look at your notes and see which one would work best for that. Very similar to this, you only have one Venn diagram and you just want to see which would work best to represent what this is. This is obviously a complement. Okay, this one we should talk about. Enter true or false depending on whether the statement is true or false. You must enter T or F. True or false will not work. Okay, the number of elements inside the set 2 is 2. Well, that is not true. I put false, but why did I put false? Because the number of elements in the set 2 is actually 1. There's only one element in there, okay? That's what the number notation is asking. How many elements are inside the set? The number of elements inside the set that just contains 2 is just 1. There's only one element inside that set. Okay. This says the number of elements inside the set that contains 3 is equal to 1. That's true by the same logic I used up here. So that's why that would be true. Okay. The number of elements that these have in common, the intersection x, y, z intersects v, w, z is 1. Is that true or false? I say that's true. They have z in common, and so this would simplify to the number of elements of just z, and that's just one element. So I would say that that's true. I would say that's true. Okay. Any questions about that one? Does that make sense how I did that?
Yeah.
Good, good, good. Okay. Okay, so for this one's going to be kind of confusing, but A and B are subsets of the universal set. A intersect B, A intersect B complement, A complement intersect B, and A complement intersect B complement are non-empty. Select which of the following to form partitions. Now remember what a partition is. A partition means there's no overlap, and there's nothing outside those sets. Okay. So you can see what I wrote as the answer, but maybe I should explain how I got it. So B and B complement. There's nothing in common there, and there's nothing outside them. So technically, that would form a partition. You could write a partition as B and B complement. That's fine. There's nothing outside B and B complement, and there's nothing in common. So you can write it that way. Okay. By the same logic, you could also write A and A complement. There's nothing outside A and A complement, and there's nothing in common. So you can write it that way. All right. What about something like A intersect B, A minus B, B minus A, and the outside? Well, I claim that if you go piece by piece, there is nothing. There's nothing in common with these statements. Say 1, 2, 3, 4. There's nothing in common between those. And if you put those all together, they would form a partition. Okay, so technically that's true. So why does A and B, just A and B, not work? Well, because they told me that A intersect B is non-empty. So there would be an overlap. And there's things outside A and B. There's also an outside. So there is an outside, so that wouldn't work. Okay, so A and B complement, that also is not enough. It's not enough. Okay. So hopefully that's a good enough hint to get started. Hopefully the logic makes sense of what I'm talking about to understand a problem like that. Okay. For this one, I'm going to work it out, I think, fully. Sets X, Y, Z form a partition in of the universal set U. The number of elements in Z equals 7 times the number of elements in Y. The number of elements in X equals 2 times the number of elements in Y, and Y equals 7. Okay, so there's a lot going on here. But the first thing we have to understand that these are partitions. If we don't understand that these are partitions, there's no way we can solve the problem. Okay, we have to understand what that means. So what does a partition mean? It means they have no intersection and there's nothing outside them. So I can draw a little picture here and I can say I have X, Y, Z. So I can write X, Y, and Z here. Okay, and there's nothing outside them. And there's no intersection. Okay, they told me that Y equals 7. Okay, they said Y equals 7. So I'll just write a 7 there. All right. They said that X equals 2 times Y. X equals 2 times Y. Well, Y is 7, so I would say that that equals 14. All right. And Z equals 7 times Y. Z equals 7 times Y, so 7 times 7 is 49. So what does the universal set equal? The sum of those. And I have 70 there. So hopefully that makes some sense to you of how I could break down a problem like that. Even though these are given to me in relation to one another, I can still solve the problem by understanding what a partition is, and I can break it down into pieces, and then I can solve the final problem. Looks like there's a question here. Next set, well, if I can say he said. Nick said that made so much sense when drawn out. Yeah, it really does. If you break it down into little pieces, and that is a goal of mine to show. If you break things down into tiny pieces, all this stuff is not very hard. If we can really break it down, most of this stuff is pretty easy. That's how I hope it comes across. It's actually pretty easy. If you know what to do and you understand what the problems are asking, for the most part, this stuff's pretty easy. I hope. I hope. Okay. Set A, B form a partition of the universal set. The universe is 99. A equals 4 times B, and C equals 7 times A. Find the number of elements in the following sets. What does A equal? What does B equal? What does C equal? Well, this one's a little bit different than the last one. In the last one, they told me I was solving for the universe, and they told me what one of the sets equaled. Now they tell me the universe, and I have to find what do they equal? What do each one equal? So I'm going to draw it out. That seemed to work last time. So maybe we'll have more luck. Now, I know that the universe equals 99. I know that that's true. So that's what they said is true, so it must be true. Okay. They told me that A equals 4 times B and C equals 7 times A. Okay. Well, how can I work with that? Well, A equals 4 times B and C equals 7 times A. Okay. But they just told me that A equals 4 times B. They just told me that. So I could rewrite this as C is 7 times 4 B's. Okay, if A is 4B, this would be 7 times 4B. Since I know that A is equal to 4B, that's what they told me, I could sub in, just like our algebra class, I could sub that in, and I would have 7 times 4B. So what's that? That would be 28B. So I have 4 B's here. I have 28 B's here. I have 1 B here. The universe equals the number of elements in A plus the number of elements in B plus the number of elements in C. So if I add these up, I could solve for B pretty easily. I could say that 99 equals 4B plus B plus 28B. And now it's just like an algebra problem. It's just like an algebra problem. So we have like 4x plus x plus 28x, just like our algebra days. Okay. From there, you can solve for b. You want to solve for b. Now what you'll do is you'll add these up. Okay. I'm going to get rid of the x part. So we got 4, 1, that's 5, plus 28, 33. What color do I use? Pink. Drawing tool. So I have 33 B's equals 99. I can divide both sides by 33, and I get B equals 3. So there we go. Now I know what that equals. So that means A must equal 4 times 3, 12. And that also means that C has to equal 28 times 3. What's that? 28 times 3, 84. So if we break it down into pieces, it's not so bad. But trying to tackle everything at once is too hard. So hopefully that gives you a bit of a hint of how to do that. I'm going to save a picture of that one for you. Hopefully that's will get you started on that homework problem. And our friend Timmy has some marbles here. We're going to talk about them. So Timmy has some red marbles, some blue marbles, some yellow marbles, and he has a total of 294 marbles. He has 6 times as many red as blue, 7 times as many yellow as red. Determine how many marbles of each does he have. Now, I would claim that this is very similar to the past 2 problems we've done. Because it's a partition problem. There's no marbles which are both red and blue. They're either red, blue, or yellow. Okay? So this is a partition problem. All right. So we, let's get my drawing tool here. So we have red, blue, and yellow. We have a total 294. Okay. We have 6 times as many red as blue. We have 7 times as many yellow as red. Determine how many of each color we have. So from there, if you use the tactics we just did in the previous problem, you should be able to solve how many marbles are there. You can see what my answers are already. Yours will be somewhat randomized. We should be able to take that information we did in the previous problem and apply it to this last problem and see this is a partition problem. Just because it's a story problem doesn't mean it's any different. And you can take those tools and apply it to this problem as well. So I'm going to leave you to this one yourself. You can see the answers. I'll leave you to do it yourself in your homework. So I hope that's enough of a running start to tackle this homework. Okay, you've seen all the homework within class, so I'm hoping that when you're on your own and you're doing this homework, it will be very approachable to do.